Good morning. In the last lecture, we've seen this theorem. Which one? Let V over F be the n-dimensional vector space. Let T be a linear operator on V. Then T is triangularable if and only if the minimal polynomial for T is the product of linear polynomials over F. Okay, if T is triangularable, then the minimal polynomial has a product of linear polynomials and vice versa. Okay, so this is the proof of this theorem. So today we will see some examples of eigenvalue. Okay, how to find the eigenvalues, that is characteristic value and characteristic vector. Okay, so question number 1, find all the characteristic values and characteristic vector of following matrices. Find the all characteristic values and characteristic vectors, okay, of following matrices. Of following matrices. First, the matrix given by 2 by 2 matrix 0 1 0 0. Second one 1 0 0 I. Okay, this is the matrix of order 2 cross 2, in which all the entries belongs to complex number. Okay, over the complex number. And third one 1 1 0 and I. Okay, so first one, matrix A is considered. A is equal to matrix of order 2 cross 2 0 1 0 0. Okay, how to find the characteristic polynomial for A? The characteristic polynomial for A or of A is given by. How to find this one? Characteristic polynomial for A. Determinant of
xi minus
I
a.
minus A. That is equal to determinant of. Okay, x minus 0. Okay, this is 1. 0 and this one is x, sorry, minus 1. Okay. So this is the determinant of x minus 1, that is x minus 1 0 x, which is equal to x into x square minus 0, that is equal to x square. So this is determinant of xr minus a, which is equal to f of x. Hence, the characteristic polynomial for a is x square. So this implies 0 is the only. Correct? 0 is the only characteristic value of A. Okay, with algebraic multiplicity 2. Okay, any doubt up to here? Now we have to find the characteristic vector now. Let's suppose capital X is equal to the column vector x1 and x2 be the coordinate matrix. Okay, coordinate matrix, that is column matrix of characteristic value, characteristic vector. This is the characteristic vector corresponds to characteristic value 0. Okay, hence by the definition of characteristic value, what we have then, A into capital X is equal to 0 into capital X. This implies what is A? 0 1 0 0. What is capital X? X1 and X2. Okay, which is equal to 0 into x1 and x2. So this implies 0 into x1 plus 1 into x2 is equal to 0 into x1 is 0, and x1 0 into x1 plus 0 into x2 is equal to 0. It implies this implies 0 is equal to 0. Okay, now here this implies x2 is equal to 0. Okay, hence we get x1 is what? X1 is arbitrary and x2 is 0, and x2 is equal to 0. Okay, this implies that capital X is equal to, suppose x1 is here what? Arbitrary, that is k. Okay, and x2 is what? 0, which is equal to k into 1, 0. Okay, any doubt up to here? So hence
No, sir.
capital K, okay, scalar multiple of 1, 0 is characteristic vector. Characteristic vector corresponds to characteristic value 0. Okay, any doubt? Okay.
No,
Now,
sir.
whether this matrix is diagonalizable. Okay, wait a minute. Solve the second one question. B. Okay, second one solve. Okay, any doubt up to here? In the first question. Now tell me whether this matrix is diagonalizable or not. This operator. So find करना है? Here the algebraic multiplicity of 0 is 2. And then what is the geometric multiplicity? Geometric multiplicity is nothing but what? Nullity of if Ci is C is the characteristic value, then geometric multiplicity for this Ci is nothing but nullity of P minus Ci into capital N. Is it correct? So here 0 is the characteristic value of the matrix A. So what is nullity of A minus Ci or Xi minus A minus 0 into I. Okay. What is A minus 0 into I? Calculate. This is 1, this is 0, 1, 0, 0 minus null matrix. Which is equal to what? 0, 1, 0, 0. What is nullity of this one? Nullity क्या है मैट्रिक्स की? This is A minus 0I is equal to this one. So nullity of 0, 1, 0, 0. काय येईल? Null space. कसं करते nullity? Rank minus n minus rank of r ना? N minus rank of A minus 0I. What is n? N is the order of that matrix, square matrix 2. What is the rank of this matrix? 1. कितनी nullity of this one?
1.
1. So here geometric multiplicity of 0 is 1. Okay, and algebraic multiplicity of 0 is 2. No? Okay, this characteristic value repeated 2 times. Okay, so here this matrix or this operator is not a diagonalizable. Okay, there does not exist any basis beta such that matrix of T with respect to that order basis beta is diagonal matrix. Okay, these are the diagonal acid diagonal matrix. आहे का diagonal matrix हा नाहीये. Okay, diagonal matrix म्हणजे फक्त diagonal entries are except other than diagonal entries all others are 0. Okay, any doubt? Okay.
No, sir.
Now the second question. Tell me what are the eigenvalues of this matrix. Consider A is equal to 1, 0, 0, R. The characteristic polynomial for A is what? F of x. F of x. Then this f of x is equal to determinant of xi minus a. Okay, now tell me the what are the eigenvalues. Find केला आणि सांगा मला पाहिजे. One and I. Okay. Now here, look at it. एखाद्या पॉलिनॉमियलचे जर रूट्स कॉम्प्लेक्स असतील तर कॉन्जुगेट पेअर मध्ये जायला हवे. ओके, if the roots of polynomial are conjugate, okay, then it comes in conjugate pair. But here we get the only one complex root I. Okay, and one other root is 1. Ka hote sir? Why this happens? Because the matrix A, all the entries from the matrix in the matrix A are complex number 1, 0, 0, 1. Okay, so has a real number real number. Okay, except suppose या आयच्या ऐवजी इथे कुठला तरी एक रिअल नंबर असला असता. Okay, instead of this I, if suppose here any real number, then it is possible. Okay, प्रत्येक काय सांगते हा कॉम्प्लेक्स मॅट्रिक्स आहे तुमचा. ओके, त्यामुळे कॉम्प्लेक्स कॉन्जुगेट पेअर्स मध्ये येतील तसं नाही. ओके, नाउ लुक एट f of x is equal to determinant of x minus 1. Okay, xi minus is what? X minus 1, 0, 0, x minus I. Okay, so this is equal to x minus 1 into x minus I, which is equal to this is f of x. Now f of x is equal to 0, so this implies x minus 1 is into x minus I is equal to 0, so this implies x is equal to 1 and I. Okay, now here the algebraic multiplicity of x 1 is 1. Again, the geometric multiplicity of I is again 1. Okay, now find the characteristic vector corresponding to the eigenvalue 1. So, characteristic vectors. Okay, characteristic vectors corresponding to characteristic vector value 1. Suppose x is equal to again x1 and x2. the coordinate matrix of the characteristic vector corresponds to characteristic value 1. Okay, then by the definition of characteristic vector, then this a into x is equal to what? 1 into capital X. Okay, which is equal to what is a 1 1 0 0 r. This is x1 and x2, which is equal to 1 into x1 and x2. Okay, any doubt up to here? So it implies x1 plus 0 x2 is equal to x1. This implies x1 is equal to x1. That means x1 is what? Arbitrary. And 0 into x1 plus r into x2 is equal to what? x2. So this implies r into x2 minus x2 is equal to 0. So this implies r minus 1 into x2 is equal to 0. So this implies x2 is equal to 0. Why? Because r minus 1 is not equal to 0. Okay, here the x2 is 0. Hence, we get x2 coordinate is 0 and x1 is arbitrary. Okay, now suppose that arbitrary element is k. X1 is equal to k. So this implies capital X is equal to k and 0, which is equal to k into 1 0. Okay, any doubt? So this is the characteristic vector corresponding to eigenvalue 1. Similarly, find the eigenvector or characteristic vector corresponding to the eigenvalue I. Find it out करायचं. Okay, find out करता का करू दे. काय येईल मग तिथे? Suppose x is equal to x1, x2 is the characteristic vector corresponding to the eigenvector I. Then we have a into capital X into I into capital X. So a is what? 1 0 0 I, which is equal to into x1 x2, which is equal to I into x1 x2. So this implies x1 plus 0 x2 is equal to I x1 and 0 x1 plus I x2 is equal to I x2. Okay, now this implies 1 minus I into x1 is equal to 0, and this implies I x2 is equal to I x2. That means x2 is what? Arbitrary. Is it correct? I get cancelled. X2 is equal to x2, x2 is arbitrary, and x1 is what? 0. So this implies capital X is equal to 0 and k is the characteristic vector corresponding to R. That is, capital X is equal to k into 0 1. Okay, any doubt? Now, whether this matrix is diagonalizable matrix. Okay, हा जो second matrix हा diagonalizable matrix आहे का? Yes, it should be a diagonal matrix system. The algebraic multiplicity of 1 is 1, which is equal to geometric multiplicity. Okay, if algebraic multiplicity 1 असेल तर तो geometric multiplicity again 1 असेल. Okay, similarly for R, the geometric multiplicity again is 1. Okay, so hence The geometric multiplicity is equal to algebraic multiplicity for each and every eigenvalue. That is characteristic value. Hence, the matrix A is diagonalizable. Any doubt? Okay. Our 33 of the
No, sir.
matrix. Okay, find the eigenvalue. Okay, third one solve करते हैं. Okay, now question number 2.
Yes, sir.
Find the eigenvalue and eigenvectors over C now. Question number 2. Okay. Here, the matrix A is given by 4, 2, 2, 3, 3, 2. Okay. Minus 3, minus 1, and 0. Okay. And the second one, this is A. A में solve करते B में solve करते. Okay. A is equal to 0, 0, minus 1, 1, 0, minus 1, 0, 0, sorry, 0, 1, 0, 0, 1, 1. Okay. Solution. A, capital A is equal to 4, 2, 2, 3, 3, 2, minus 3, minus 1, 0. Okay, calculation could have okay, now the characteristic polynomial for A is given by characteristic polynomial of matrix A is determinant of xi minus A, which is equal to determinant of what is xi minus A? X minus 4, 2, 2. Minus 2, no? Okay, calculation was चुका था लक्ष्य देखते हैं. Minus 3, x minus 3, minus 2, 3, 1, and x minus 0, that is x. Is it correct? Now tell me what are the
Yes, sir.
eigenvalues, characteristic values. हाँ, हम calculation solve करते हैं. करते calculation करते समय मला सांगा तुम्हाला. Minus plus minus 2 minus 3. This is minus 3 into x minus 3. Is it correct? This step? Okay. It is equal
Yes, sir.
to x minus 4, x squared minus 3x plus 2. Okay, plus 2 as it is. This is minus minus 3 into 2 minus 6x plus 12. Okay, minus 2 into that minus 3, but minus 3 into minus 3x plus 9, which is equal to this is x minus 4. This is x squared minus 3x plus 4 minus 6x plus 10, no, plus 12 minus 3 plus 9, 6, 6 2s are 12. Okay, minus minus plus, this is 6x. Up cancel. Okay, which is equal to x minus 4. And this is 2 आहे ना. म्हणतोय मी चुकलो तरी सांगा, लक्ष नाही कोणाचं. ओके, काय येईल हा? Multiplication 2, addition minus 3, x minus 2, x minus 1. Is it correct?
Yes, sir.
So this is equal to x minus 4, x minus 2, x minus 1. So this is f of x. If it is equal to 0, This implies x is equal to 4, 2, and 1. Okay, any doubt?
No, sir.
Okay, now the characteristic value corresponding to the eigenvector 1. Characteristic vector corresponding to the characteristic value 1. Okay, let capital X is equal to x1, x2, and x3 now. Okay, be the eigenvector or characteristic vector. Okay, corresponding to eigenvalue 1. Then a into x is equal to 1 into x. What is a? 3, 2, 2. Okay, 4, 2, 2. Sorry. 4, 2, 2, 3, 2, and minus 3, minus 1, 0. Okay, this is a. Now x is, what is x? x1, x2, x3. Reply that I agree. Okay, x1, x2, x3. Okay, now tell me the three equations. We have to find the value of x1, x2, x3. This implies 4x1 plus 2x2 plus 2x3 is equal to x1. Okay, so this implies 3x1 plus 2x2 plus 2x2 x3 is equal to 0. Okay, second 3x1 plus 3x2. Okay, 3 into x1 कसं करते कळते ना हे मॅट्रिक्स मल्टिप्लिकेशन
Yes, sir.
ही सांगू दे. Okay, 3 into x1 plus 2 into x2 plus 3 into x2 plus 2 into x3 is equal to x2. This implies 3 into x1 plus x2 get cancelled. This is 2 into x2 plus 2 into x3. Those are the equation. Okay. And third one, minus 3x1 minus x2 is equal to x3. So this implies 3x1 minus x2 plus x2 is equal to plus x2. Okay. Minus x1. Is it correct? Okay. Now tell me what
Yes,
are the
sir.
values of x1, x2, x3. काय येतील? चुकलंय का? कुठे चुकलंय का काही? म्हणजे मला दोनच इक्वेशन आली. Hence we get two equations. 3x1 plus 2x2 plus 2x3 is equal to 0. Okay. And 3x1 plus x2 plus x3 is equal to 0. Okay. हे तीन दोन इक्वेशन मला आले. If suppose x1 is equal to 0, what we get? If x1 is equal to 0, then 2x2 plus 2x3 is equal to 0. So this implies x2 is equal to minus x3. Okay. Hence, this implies if x2 is equal to 1, then x3 is equal to minus 1. Is it correct?
Yes, sir.
Okay. So what we get? So capital X is equal to हा तुमचा x1 इथे independent आहे. 3 equations, 3 unknowns and 2 equations. Independent solution. Sorry, infinite solution we get. ओके. सो हियर x1 इज इंडिपेंडेंट. समा हा तुमचा इंडिपेंडेंट आहे आणि हियर द x2 डिपेंड ऑन x3 ना. Okay, so here x1 is 0, x2 is 1, x3 is -1. Okay, so hence this is the what characteristic vector corresponding to characteristic value 1. Any doubt? काही डाऊट आहेत का? समजतंय का सगळ्यांना? Okay, similarly you
Yes.
can find the characteristic vector corresponding to the eigenvalue 4 or eigenvalue 2. Okay, 2 साठी करूयात आपण. Now let again y is equal to, now suppose y1, y2 and y3 is the characteristic vector corresponding to characteristic value 2. Then what we get? Ax is equal to, sorry, ay is equal to 2y into capital Y. So this implies what is A? 4, 2, 2, 4, 2, 2. Okay. 3, 3, 2, minus 3, minus 1, 0 into y1, y2, y3 is equal to 2 into y1, y2, y3. Okay, so this implies 4y1 plus 2y2 plus 2y3 is equal to what? 2y1, and 3y1 plus 3y2 plus 2y3 is equal to 2y2, and minus 3y1 minus y2 is equal to 2y2. Okay, now so this implies काय equation होईल? काय येईल? 3y1 minus 3y2 is equal to 0. So this implies y1 is equal to y2. Y3, sorry. Okay, sorry. Okay, this one is 3y3. Okay, wait a minute. Now, so this implies 2y1. Okay, 4 minus 2 is 2 plus 2y2 plus 2y3 is equal to 0. That means y1 plus y2 plus y3 is equal to 0. Okay, from this one now, 3y1, 3 minus 2, 1, y2 plus 2y3 is equal to 0. Okay, and from this one, 3y1 minus, काय म्हणलात? Any doubt?
3y1 plus y2.
3y1 minus y2 minus 2y3 is equal to 0. म्हणजे हे दोन इक्वेशन कसे आले? सेम आले. ओके, दॅट मीन्स इंडिपेंडेंट आहे. कुठे कुठे?
सेकंड इक्वेशन.
हो. सेकंड इक्वेशन, वेट, 3y1
y2 plus 2y3
plus y2, yes, plus 2y3 is equal to 0. And this one is 3y1 minus y2 minus 2y3. Okay, this is plus 3 minus 2. Okay, हे कॅल्क्युलेशन चुकतं कधी कधी, त्यामुळे प्रॅक्टिस हवी असेल. काय येतील मग व्हॅल्यूज? y1, y2, y3. सपोज y1 is equal to 0. y1 0 घेतल्यानंतर काय येईल? This implies y2 is equal to minus y3. काय केली?
सर थर्ड पण y2 आणि y3 प्लस
कुठे?
येते.
इथे
Third
Third
equation.
equation 3y1 minus y2 ना correct मैट्रिक्स क्या है तुमचा -3 -1 है ना
Plus
मैट्रिक्स
है ना?
ओके -3y1 ओके हा तुमचा -3y1 ओके -y2 0 into y3 0 which is equal to 2y3 okay now हा काय आला इकडे आला wait हा -3y1 -y2 हा इथं मायनस येतोय ना करेक्ट म्हणजे हा आला प्लस 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 ओके मी आता असं सॉल्व्ह करतो तुमच्या समोर ही काही तयारी केली नाही ओके सो व्हॉट वी गेट y1 प्लस y2 प्लस y3 इज इक्वल टू 0 ओके हे दोन्ही इक्वेशन सेम आले तुमचे दिस टू अँड 3y1 प्लस y2 प्लस 2y3 इज इक्वल टू 0 ओके टू इक्वेशन 3 अननोन्स म्हणजे एक तुमचा इंडिपेंडेंट आहे कोणतरी सपोज y1 इज इंडिपेंडेंट सपोज टेक y1 इज इक्वल टू 0 then what we get y2 is equal to minus y3 okay and y2 is equal to minus y3 then y is equal to 0 if y2 is 1 y3 is minus 1 hi okay wait it is 1 minus 1 y2 is equal to minus 2y3 y2 असेल तर किती येईल minus 2 y3 that means y3 is equal to minus 1 by 2 येईल म्हणजे y मध्ये काय आहे कॅपिटल y 0 1 minus 1 by 2 हा तर इकडे आला आहे हे एक्झाम्पल मी उद्या सांगितलं कारण की हा इथे आला आहे वेक्टर कॅरेक्टरिस्टिक वेक्टर करस्पॉन्डिंग टू 1 पण येतो आणि करस्पॉन्डिंग टू 2 पण येतो नाही कुठेतरी चुकतंय minus 2 is 2 2 get cancelled y1 plus y2 plus y3 is equal to 0 this is 3y1 plus 3y2 plus 2y3 is equal to 2y2 okay yeah 3y1 plus y2 plus 2y2 okay. From this 2 1 right हा याच्यामध्ये काय इक्वेशन ओके एक्झाम्पल उद्या सांगेल मी एक तर हा तुमचा कॅरेक्टरिस्टिक वेक्टर येईल किंवा हा कॅरेक्टरिस्टिक वेक्टर येईल चेक करूया थांबा व्हॉट इज 8 4 2 2 3 3 2 -3 -1 0 ओके समजा हा घेऊया 0 1 -1 by 2 ओके काय करू त्याचा 4 into 0 0 2 minus 2 ना 2 minus 2 into 1 by 2 1 okay now 3 into 0 0 3 into 1 3 2 into 1 minus 1 by 2 minus 1 minus 3 into 0 0 minus 1 into 1 is 1 okay hi then 1 to 1 okay ito kayo into 1 which is equal to 2 into high na x so 1 minus 1 by 2 ito ka 2 ito 1 ito 0 यायला ओके इथे कुठे चुकते हा कॉर्डिनेट चुकते तुमचा इथे 0 असेल हो ना करेक्ट 2 into 1 2 2 into minus 1 by 2 minus 1 ओके हे एक्झाम्पल उद्या सांगेन ओके, समझते हैं कैसे फाइंड आउट करायचे. Okay, similarly you can find characteristic vector corresponding to the eigenvalue 4.
Yes, sir.
Okay. Now the next question, find the minimal polynomial for the real matrix. How to find the minimal polynomial? Okay. Characteristic polynomial तर माहिती आहे कसं लिहायचं. Determinant of xi minus a is nothing but characteristic polynomial for that matrix. Okay, now we have to find the minimal polynomial of a real matrix. Question, find the minimal polynomial for the real matrix. And the matrix is given by capital A is equal to 7, 4, minus 1, 4, 7, minus 1, minus 4, minus 4, 4. Okay, first find out the characteristic polynomial. How to find the characteristic polynomial? Determinant of xi minus a. This is x minus 7 minus 4, 1, minus 4, x minus 7 plus 1, 4, 4, x minus 4. Is that correct? Which is equal to x minus
Yes, sir.
7, x minus 7 into x minus 7 into x minus 4. X minus 7 into x minus 4 minus 4. Okay, minus minus plus, this is 4. Minus 4 into x minus 4 minus 4 plus 1. 4 for the 16. So this is minus 16 minus 4 into x minus 7. Okay, now tell me the eigenvalues or f of x, the characteristic polynomial. Try. Solve को करते solve. Okay, so at last we get x minus 3 bracket square into x minus 12. Okay, so the characteristic polynomial for a is x minus 3 bracket square into x minus 12. Now here the algebraic multiplicity of 3. Okay, x minus 3, this factor repeated 2 times. Okay, now we have to find the minimal polynomial for a. Okay, we have one theorem. Every root of characteristic polynomial is also root of minimal polynomial. Okay, प्रत्येक root x polynomial characteristic polynomial चा प्रत्येक root हा काय असतो? Minimal polynomial चा root असतो. Okay, hence the minimal polynomial m of x of capital A is either x minus 3 into x minus 12 or x minus 3 bracket square into x minus 12. Okay, now look at here. What is m of x? M of x, there are two possibilities for m of x. Either x minus 3 into x minus 12 or x minus 3 bracket square into x minus 12. Okay, this is the characteristic polynomial and this one is the minimal polynomial. Look at it. The characteristic root of characteristic polynomial is always root of minimal polynomial. Okay, except their multiplicities. एक तर हा असू शकतो किंवा हा नसेल तर काय असतो, हा असतो. Is it correct? प्रत्येक फॅक्टर हा तुमच्या मिनिमल पॉलिनॉमियल मध्ये यायला हवा, लाईक x minus 3 आणि x minus 12 except their multiplicities. ओके, मल्टिप्लिसिटी डिफरंट असू शकते असं म्हणायचं. सो x minus 3 into x minus 12, either this one or x minus 3 bracket square into x minus 12. This one will be minimal polynomial. Now check for these two polynomials whether the matrix A satisfies this polynomial or this one. Okay, now wait a minute. Wait a minute. What are the two possibilities? Suppose this is m1 of x, minimal polynomial, x minus 3 into x minus 12. And what is m2 of x? X minus 3 bracket square into x minus 12. Okay, let us check for m1 of x whether this A satisfies m1 of x or m2 of x. Let us check the minimal polynomial, that is m1 of x is equal to x minus 3 into x minus 12. Annihilates A or not? Annihilates A or not? Okay. What is m of x? m1 of x is equal to x minus 3 into x minus 12. What is m1 of A? X minus, sorry, A minus 3 है ना? Okay, is it correct? Into A minus 12i.
Yes, sir.
A काय आहे तुमचा? A is equal to, what is A? 7 4. Okay, the बाजूला घेऊ directly.
7.
Okay, sorry. Suppose this one is A. 5 7 8 7 4 minus 1 4 7 minus 1 minus 4 minus 4 and 4. Okay, now tell me A minus 3 here. A minus 3 here can say 7 minus 3 3 4 minus 1 4 7 minus 3 sorry 4 yeah. 7 minus
4.
3 is 4 4 4 minus 1 now 4 4 minus 1 minus 4 4 this is 1. Is it correct? Into now A minus 12i 7 minus 12 minus 5. Okay, 4 minus 1 4 7 minus 12 minus 5. Wait. Minus कितना है? A minus 3 yeah. Diagonal 7 minus 12 is minus 5 minus 1 minus 1. This is minus 4 4 4 minus 12. Okay, is it correct? कुछ कुछ नहीं है ना कैलकुलेशन कुठे
Third row.
हाँ इथे minus
Minus
4
4 आणि minus 4.
okay, minus 4 now do the multiplication of these two matrices whether this one is null matrix finally to null matrix पर check करो इथे का correct check. What is the first entry? 4 into minus 5 minus 20. 4 into 4 it's 16 na? 4 into 4 16 minus 1 into minus 4 is plus 4. Okay, काय आला है 20 minus 20 0. सगळं एंट्रीज काय येतात 0 0 0 0 0 0. ओके सगळं येतं चेक करा तुम्ही. Okay, that is null matrix na? Okay, hence m1 of A is equal to null matrix. Okay, that is m1 of x is equal to x minus 3 into x minus 12 annihilates A. Okay, and also m2 of x is characteristic polynomial x minus 2 3 brackets into x minus 12 also annihilates because it's characteristic polynomial and every square matrix satisfies characteristic polynomial by Hamilton theorem. जर सॅटिस्फाय झाला नसता, इथे कुठली तरी एंट्री नॉट झिरो आली असती, ओके, नॉट नल मॅट्रिक्स आला असता, तर या एंट्री ऑफ एक्स चेक करायची गरज नाही तुम्हाला पुन्हा. वाय? बिकॉज इट इज ऑलवेज हा आधीपासूनच काय तुमचा कॅरेक्टरिस्टिक पॉलिनॉमियल. ओके, इज इट करेक्ट? ओके, इथे m1 ऑफ एक्स हा तुमचा
Yes,
सॅटिस्फाय
sir.
करतोय म्हणून ठीक आहे. ओके, here the degree of m1 of x is less than degree of m2 of x. Okay, hence m1 of x is what? Minimal polynomial. Okay, जर हा satisfy झाला नसता m1 of x, then there is no need to check for m2 of x. Why? Because already m2 of x is nothing but the characteristic polynomial. Okay, पुन्हा तिथे वेळ घालत बसू नका. ओके, तर युनिव्हर्सिटीची एक्झाम असेल तर चेक करू शकता. कुठे सेटला नेटला तुम्हाला चेक करायची गरज नाही. m1 of x नॉट आता सॅटिस्फाय होत नसेल, सपोज m1 of x is not annihilates a, then डायरेक्टली काय म्हणू शकतो आपण, m2 of x that is characteristic polynomial also annihilates. Okay, आता annihilate करतोच, hence this implies m1 of x is equal to x minus 3 into x minus 12 is minimal polynomial. Okay, any doubt or a?
No, sir.
ओके, समजा इथे पॉवर 3 आली असते तर काय केलं असतं तुम्ही, कॅरेक्टरिस्टिक पॉलिनॉमियलची एफ ऑफ एक्स क्यूब आला असता, तर किती पॉसिबिलिटी झाली असते, हा तर एक पॉसिबिलिटी झाला असता, हा एक पॉसिबिलिटी, और 3 पॉसिबिलिटी असते है ना.
Yes, sir.
ओके, 3 पॉसिबिलिटी असते. समजा इथे हा स्क्वेअर पण असला असता, मग काय झाले असते, किती पॉसिबिलिटी आली असते, 3 into 2 6 पॉसिबिलिटी आली असते. ओके, कोणकोणत्या पॉसिबिलिटी पहा, चेक करू. इफ सपोज कॅरेक्टरिस्टिक पॉलिनॉमियल x minus 3 क्यूब and x minus 12 स्क्वेअर असला असता, फर्स्ट पॉसिबिलिटी m1 of x, x minus 3, x minus 12, x minus 3 square, x minus 12, x minus 3 cube, x minus 12. Okay, now x minus 3 square, x minus 12 square, x minus 3 square, x minus 3 square, having first less than x minus 3 square. Right. 6 possibility आले असते. x minus 3 square, x minus 12 square, x minus 3 cube, x minus 12 square. अजून एक पॉसिबिलिटी काय आहे का, तो एक ना, हा पण असला असता,
x minus
square
3 into x
x minus 12, is it correct? अच्छा ठीक आहे,
minus
किती पॉसिबिलिटी, 6 पॉसिबिलिटी यायला लागले, 3 plus 6 5 झाले. x minus 3, x minus 12 square. Okay, आले का 3 साइड्स पॉसिबिलिटी, 2 3 4,
x minus 3 into x minus 12.
x minus 12, एकदा हे चेंज करायचे, एकदा हे चेंज करायचे. ओके, कळते का, एकदा हे फिक्स ठेवा, कशा पॉसिबिलिटी फाइंड आउट करायच्या. ओके, सो मिनिमल पॉलिनॉमियलच्या किती पॉसिबिलिटी आल्या असतील, 6 पॉसिबिलिटीज. ओके, प्रत्येक कसं करणार, त्या प्रत्येकाला चेक करून बसवणार तुम्हाला, हा एकदा, हा एकदा, हा एकदा, हा एकदा. ओके, आणि एवढे एक मोठे एक्झाम्पल देत नसतात. ओके, एनी डाउट? ओके, हाउ टू फाइंड मिनिमल पॉलिनॉमियल. ओके, एक एक्झाम्पल देतो ते होमवर्क करतो.
No, sir.
हाच एक्झाम्पल, सपोज तुमचा मिनिमल पॉलिनॉमियल जर कॅरेक्टरिस्टिक पॉलिनॉमियल असा असला असता, तर काय केलं असतं तुम्ही, f of x is equal to 3/3 चा मॅट्रिक्स आहे, x minus 3, x minus 4 and x minus 5. मिनिमल पॉलिनॉमियल, so this is characteristic polynomial. What are the possibilities of minimal polynomial? We know that every root of f of x must be root of m of x, minimal polynomial. म्हणजे ह्याच्यात एक तरी फॅक्टर असायलाच हवा. But in the characteristic polynomial, algebraic multiplicity of each and every factor is 1. Okay, it implies that in the minimal polynomial, we have again the multiplicity of each and every factor is again 1. So this one is minimal polynomial. So hence the characteristic polynomial and minimal polynomial are same. If the characteristic polynomial contain every factor repeated only one times. ओके, एकदाच रिपीट झालेला असेल तर तोच मिनिमल पॉलिनॉमियल येतो, पुन्हा चेक करायची गरज नाही. ओके, कळतंय काय सांगतोय? ओके, नी डाऊट अप टू हियर?
Yes, sir.
ओके, ज्यांनी कॉम्पिटिशन मध्ये